Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. If you have not already subscribed, please subscribe my channel. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test held in the month of March 2025. It is a rescheduled examination for Assam Center. In this video, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the annihilating polynomials of a given linear transformation. And this question is placed in part B, which is a multiple choice question. It carries 3 marks. And the question ID is 706508. Further, this question is suitable for all these examinations. Right. The given question is, let T be a R linear transformation from R power 4 to R power 4. So we have a R linear transformation T from R power 4 to R power 4 such that T square plus T plus I in brackets followed by T minus 2I is equal to 0, and T square plus T plus 2I into or followed by T square minus 4I is equal to 0. Then which of the following statements is false? We have to find out a false statement from the following 4 options. We are given 4 options. Option 1, T is diagonalizable over R. Option 2, the characteristic polynomial of T is x minus t whole to the power of 4. Option 3, the characteristic polynomial of t is x square plus x plus 2 multiplied by x square minus 4. Option 4, for every R linear transformation S from R power 4 to R power 4, we have ST is equal to TS. Right. Let's now discuss the solution of the problem in detail. We have a R linear transformation T from R power 4 to R power 4. We are given T square plus T plus I followed by T minus 2I is equal to 0. And T square plus T plus 2I multiplied by T square minus 4I is equal to 0. What's the meaning of this? The meaning of this is x square plus x plus 1 multiplied by x minus 2 is an annihilating polynomial of T, and x square plus x plus 2I multiplied by x square minus 4 is also an annihilating polynomial of T. That means P of x is equal to, let's call this as this polynomial as P of x is equal to x square plus x plus 1 multiplied by x minus 2, and Q of x is equal to x square plus x plus 2 into x square minus 4 are annihilating polynomials of the linear transformation T. Right. So then we remember the definition of the minimal polynomial. The minimal polynomial denoted by mt of x is the monic polynomial of least degree such that mt of t is 0 and it divides every annihilating polynomial. Right. So this implies the minimal polynomial of t divides p of x, because p of x is an annihilating polynomial. The minimal polynomial of x, the minimal polynomial of t divides q of x, because q of x is also an annihilating polynomial. So the minimal polynomial of t divides both p of x and q of x. So the minimal polynomial of t must be the GCD, the greatest common divisor of the polynomials p of x and q of x. Look at these two polynomials p of x and q of x. What is the great x minus 2 is a common divisor, because in q of x, x square minus 4 is there, that is x plus 2 into x minus 2. So x minus 2 is a common divisor, and it is the greatest common divisor. You can see very easily. So therefore, the minimal polynomial of t is x minus 2. Right. So that's what we have. It's a very important, information what we have brought. Right. Now further, mt of t, the minimal polynomial of x satisfies t, therefore mt of t is 0, that is t minus 2i is equal to 0. Agreed. We move on to the next slide for the further discussion. So t minus 2i is equal to 0 means t is equal to 2i. Right. We take the option 1. T is diagonalizable over R. Is it so? Now, remember, we have the minimal polynomial of x, the minimal polynomial of t is x minus 2, and thereby we got t is equal to I. But anyway, we are interested in this. The minimal polynomial of t is x minus 2, and there is a important result connecting the behavior of the minimal polynomial of a linear transformation and the diagonalizability. What is that? T is diagonalizable over R if and only if the minimal polynomial of t has distinct non-repeated linear factors. Non-repeated, distinct is one and the same, but anyway, non-repeated linear factors. Look at the minimal polynomial of t, x minus 2. So it has a non-repeated linear factors. There is only one factor, that's linear. Therefore, t is diagonalizable. Option 1 is true. Right. But we have to find out that option which is not true, which is a false statement we have to find out. Option 2. The characteristic polynomial of t is x minus 2 to the power of 4. Option 3. The characteristic polynomial of t is x square plus x plus 2 into x square minus 4. Right. Recall, all the eigenvalues of t are the roots of the minimal polynomial. Now, what are the roots of the minimal polynomial? 2. 2 is the only root. Therefore, all the eigenvalues of t must be 2. When all the eigenvalues of t is 2 only, and t is from r power 4 to r power 4, it must be, the characteristic polynomial must be x minus 2 to the power of 4. Right. Therefore, the characteristic polynomial of t is x minus 2 to the power of 4. Right. So thus, option 2 is true and option 3 is not true, because if you say that x square plus x plus 2 into x square minus 4 is a characteristic polynomial, is the characteristic polynomial, then look at x square minus 4, x plus 2 into x minus 2. That means minus 2 is an eigenvalue of t. But all the eigenvalues of t are the roots of the minimal polynomial. The minimal polynomial has only one root, 2. So all the roots of the characteristic polynomial must be 2. But how come this characteristic polynomial is enjoying an eigenvalue plus 2? Therefore, option 3 is not true. So option 2 is true and option 3 is not true. And we are looking for a false statement. Therefore, our answer should be option 3. But anyway, we will look into the leftover option, option 4. For every R linear transformation S from R power 4 to R power 4, we have ST is equal to TS. SNT commutes. Now, let S from R power 4 to R power 4 be any R linear transformation. Then ST operating on X is equal to S of Tx. That is equal to S of T of X. What is T of X? Is 2x. So M is equal to 2i. T is equal to 2i. T of X will be 2 times I of X, that is 2x. So S of 2x. S of 2x is equal to 2 times S of X, because S is a linear transformation. True for all x belongs to R to the power of 4. And Ts operating on X is equal to T of S of X. T of S of X will be 2 times S of X, because T of X is equal to 2x. So therefore, T of S of X will be 2 times S of X. So there, for all x belongs to L to the power of R to the power of 4. Thus, we have St of X is equal to Ts of X for all x belongs to R to the power of 4. Therefore, St is equal to Ts. Thus, the option 4 is true. And we have to find out that option which is false. Therefore, our answer to this question is option 3. And that is the detailed discussion of the solution of the given problem from the section Linear Algebra, which is based on annihilating polynomials. And it is definitely a good question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join in my channel as a member and support me and my channel. If you have not already subscribed, please subscribe my channel. Yes. We will meet once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.